Uh, my name is Itianit Jude, and I would like to speak about the history of computers. Beginning with the first generation, the first generation used vacuum tubes for digital logic elements and memory. Then the fundamental approach was program concept and was attributed to the mathematician called John von Neumann. John von Neumann first published this idea in 1945 for the EDVAC. The EDVAC stands for the Electronic Discrete Variable Automatic Computer. Design began at the Princeton Institute for Advanced Studies. They completed it in 1952 and started in 1945 by John von Neumann. Um, in 1945, in 1943, John Matthew proceeded to build an electronic computer called ENIAC. ENIAC stands for Electronic Numerical Integrator and Computer. Other computers were invented, for example, EDSAC, WESIAC, MANIAC, ILIAC, and so on. The IAS computer working on the IAS structure. Then that is for the first generation. For the second generation, they simply use transistors. The transistors were small and cheaper. They dissipated less heat than a vacuum tube. That's why they were preferred more than vacuum tubes. A transistor is just a solid state device made from silicon and was invented in Bell Labs in 1947. But it was not commercially available in the markets until late 1950s. Now, in this second generation, which was characterized by the use of transistors, the operations per second, the operating speed was 200,000 operations per second compared to the 40,000 operations per second of the vacuum tubes, which was of the first generation. Now, they introduced more complex and logical units together with control units. The use of high-level programming languages started. Provision of system software was provided, meaning everyone had to load his own software before he could use the computer. This software was used to load programs, move data to peripherals, then libraries perform common computations. A very good example of the second generation transistors includes the IBM 7094 computer. Moving on to the third generation, we have the integrated circuits. This third generation used the integrated circuits, and it was invented in 1958 approximately. An integrated circuit is a discrete component, self-contained transistor, and their speed was characterized by small and medium scale integration of 1 million operations per second. They were manufactured separately, packaged in their own computer, in their own containers, and soldered or wired together onto Masonite-like circuit boards. Manufacturing was expensive, of course. Yeah, but it was better than the transistors of the second generation. Then when we go to the characteristics of integrated circuits, we would say data storage was processed by memory cells. Yeah, data processing was processed by the gates. These gates, they just perform Boolean and logical functions. Then data movement was provided by the paths among the components, maybe from memory cell to memory cell or memory cell through gate to memory cell. Therefore, the computers consist of gates, memory cells, and interconnections, which are still known as paths. Many transistors can be produced at the same time on a single chip. Yeah, on a single chip or a single wafer of silicon. Transistors can be connected with a processor metallization to form circuits. Now, in this very generation, we observe a man called Gordon Moore. Gordon Moore had a law of 1965, and he was the co-founder of Intel. He observed that the number of chips, the number of transistors that could be put on a single chip was doubling every year. And as we know, every law has its own consequences. We can go to the consequences of Moore's law. One of the consequences of Moore's law is that the cost of computer logic and memory circuitry has fallen at a dramatic rate. Then the electric path is shortened. How was it shortened? Because very many transistors could be put on the same chip, therefore it was shortened, increasing on the operating speed. Computers became smaller and more convenient to use in a variety of environments. Then a reduction in power, since the components were reduced, the interconnections were reduced, so even the power and the cooling requirements also reduced. Then fewer inter-chip connections, since they could all be put on the same chip. We move to the fourth generation. The fourth generation was categorized by large-scale integration, and the large-scale integration had the operating speed of 10 million, of 10 million operations per second. Now from here, tens of thousands of transistors could be put on a single chip. This led to reduced size of computers. Software was simplified. Software was not supplied, meaning the user had to write his or her own. Then we hear of the Macintosh. The Macintosh came after the fall of Apple Lisa and was the first computer to come with GUI. GUI simply stands for Graphical User Interface. Portable computers were invented, for example, the Osborne 1 at only 11 kilograms. Simply 11 kilograms. Then during this era, Intel also produced 8386 with a 32-bit CPU. Yeah, it was some improvement. 32-bit, it could handle 32 by bits at the same time. Invented a computer chip called field programmable gate array, containing a large supply of generic logic gates. Yeah, that's all for the fourth generation. For the fifth generation, it is categorized by very large scale integration. The very large scale integration, the computer is reduced in size and they're easy to carry, just like now the phones, the smartwatches, the tablets, the PDAs. Yeah, the PDA is standing for personal digital assistants, and smartphones evolved like now. Then an input technique called graffiti, developed by Jeff Hawkins, led to faster and more reliable writing on the PDAs. As you know, the power reduction is reduced, so it was categorized by low power consuming and invisible computers. Yeah, invisible computers, and the operating speed was 100 million 100 million operations per second. Now that is where we are right now, so we can move to the Intel x86 architecture. The Intel x86 architecture represents the decades of design effort on CISC. CISC stands for Complex Instruction Set Computers. And if we start speaking about the highlights of the Intel product line, we have the 8080. The 8080 was the world's first general purpose computer. It was an 8-bit machine with 8-bit data path to memory. It was used in the first PC called Altair. When we move to the 8086, that was the first appearance of the x86 architecture. It was a 16-bit machine and had an instruction cache or queue that prefetches a few instructions before they are executed. This is what they refer to as pipelining. Pipelining is the collecting of another instruction before the machine cycle of the first instruction has not been completed. Then we have the 8286. This was just the extension of 8086, but it had a 16 MB memory instead of just 1 MB. Moving on to the 8386, it was the first 32-bit machine of Intel, first Intel processor to support multitasking. carrying very many tasks at the same time. Then we have the 8486. This one introduced the use of more powerful cache technology and instruction memory. Cache is just a small memory which is very powerful, that helps the computer to run very quickly, and that is where the commonly used instructions or programs are stored. It's very small but very fast. Also, under the 8486 also offered a built-in math coprocessor. That was mainly for the mathematicians. Moving on to the Pentium. Pentium now, this is the one that we have in our laptops or our computers. The Pentium, Intel introduced the use of superscalar techniques, which allow multiple instructions to execute in parallel, what they call parallel processing. Then moving on to the Pentium Pro, I'm listing them in order. Moving them to the Pentium Pro, continued the move into superscalar organizations with aggressive use of register renaming, branch prediction, data flow analysis, and speculative execution. Going on to the Pentium 2, the Pentium 2, the Intel, the one which makes Pentium, added the MMX technology, which is designed specifically to process video, audio, and graphics data efficiently. Pentium 3 added additional floating point instructions. Pentium 4 included additional float pointing and other enhancements for multimedia, such as audio, video, photos. Then we have the Core. The Core was the first Intel x86 micro core. That was for the Core. Moving on to the Core 2. Core 2 was a 64-bit core architecture. Core 2 Quad Core produces 4 cores on a single chip. As we know, quad means 4. Yeah, quad means 4. Then more recent core offerings have up to 10 cores per chip. That is now, but when it began, there were only 4. Then moving on to the evolution of the ARM architecture. The ARM refers to a processor architecture, and it evolved from RISC. RISC stands for Reduced Instruction Set computers. It is the mainly used architecture nowadays, so it's on market very well. It was produced by Acon. Yeah, it was produced by ARM Holdings, and the ARM Limited was just a partnership from Acon, VLSI, and Apple Computer in the 1990s. But the first one was produced by Acon RISC version ARM1 in 1985. Then the ARM products, we have the Cortex A/Cortex A50. These were intended for mobile devices like smartphones and consumer devices like digital TVs. They operated at a higher clock frequency of over 1000 megaamperes, that's 1 gigahertz, and supported MMU. MMU stands for Memory Management Unit, which is a hardware module that supports virtual memory and paging by translating virtual pages into physical addresses. Both of these were using ARM and Thumb2 instruction sets, but the only difference was that Cortex A was 32-bit while Cortex A50 was a 64-bit. Moving on to the Cortex R. The Cortex R was designed to support real-time applications such as mobile banking, mass storage controllers, and they were operating at a very high clock frequency from 200 megahertz to 800 megahertz. It never supported MMU, so for them they had MPU, standing for Memory Processing Unit. Memory Processing Unit was just a hardware module that prohibits one program in memory from accidenting memory assigned to sorry for that disturbance, but my phone could not record a very long video. Let's continue to the Cortex M. The Cortex M was designed for microcontroller domain, where the need for fast, highly deterministic interrupt management is coupled with a desire for extremely low gate count and lowest possible power solution. It supported MMU it supported MPU just like Cortex R. It used only thumb 2 instruction sets and was developed for IoT devices, that is Internet of Things devices, wireless sensor networks, automotive body electronics. Then the Cortex M has 4 versions. To begin with, we can start with the Cortex MO. The Cortex MO was designed for 8-bit and 16-bit applications. It had low cost, ultra low power, and simplicity. It was simple to use. Small silicon die size and lowest chips, so it was cheap in actual sense. Moving on to the Cortex MO Plus. It was an enhanced version of the MO that is more energy efficient. Then moving on to the Cortex M3, designed for 16 and 32-bit applications. It was emphasizes higher performance and energy efficiency. Has comprehensive debug and trace features to enable software developers develop their programs quickly, since it could show you where the problem is, other than the others which could not show you where the problem is in your code. The last one is Cortex M4, was the enhanced version of Cortex M3 with additional instructions to support digital signal processing tasks. That is the end. Thank you.